Hi guys, this is Hw8. I'm doing homework 8, question number 2. We're given that x and y have joint density function fxy equal to a times the absolute value of x plus y when x is smaller than the absolute value of y, but in between 0 and 1. We have to take in consideration of two cases when y is positive and when y is negative. So the first case, when y is positive, we have a times the absolute value of when a times the absolute value of x plus y is just a times x plus y. But when y is negative, this a times the absolute value of x plus y becomes negative a times x plus y. So then we do the double integral for a times x plus y, and we get 3/2 times a times 1/3 y/3 between 0 to 1 is just 1. And we do the double integral for negative a times x plus y. We have 1/6 times a. So in order to make this fxy function be a valid joint density function, we have to combine these two parts. So we add them up. They should equal to 1 in order to make this a valid joint density function. So what we get before, we have 1/2 of a, so this is 3/6 of a plus 1/6 of a, which is 3/3 of a equal to 1, so a is 3/2. Now part B gives us z equals to x times y, and we set w equal to y. We have the j function equal to the matrix dz dx, dz dy, dw dx, and dw dy. dz dx is y, dz dy is x, and dw dx is 0, and dw dy is 1. And we find the value of the matrix is just y times 1 minus 0. So this equal to y, and this j is just w, right? Because we set w equal to y. So now we can find x1 is just x is z over w, since w is y, and then y1 is just w. We also have to think this question in two cases. When y is positive, we have z over w, which is x, smaller than y, smaller than 1. And we multiply w to each of them, we get z smaller than w squared, smaller than w. And since this whole thing does not exceed 1, so this is so when we take the square root of them, we have square root of z smaller than w smaller than 1. I rewrite the thing we talked about before here, and then now for fcw, it's just fcw x1 y1 over the square root of j, which square root of j is just w, right? And x1 is z over w and y1 is w. So fz of z is the integral of 3/2. This is a times x plus y, so 3/2 times z over w plus w over w dw is equal to 3/2 the integral of z over w squared plus 1 dw equals to this, and then we from square root of z to 1, we plug in 1 first, and then minus we plug in the square root of z. These two cancel out, we get 3/2 times 1 minus z. And then the second case, when z is smaller than 0, we have -1. I will show you this here. Sorry. I have it here, -1, smaller than w, smaller than -c over w. So -1, w, -c over w. -1, w, -z over w. And the same thing we did before, we multiply w to each of them, and then we take the square root of them. But be careful of the sign here, since this is since w is negative, so when we take the square root of the w squared, we get -w. So in this case, this is actually positive now. So same thing as before, this whole thing is larger than -1, so we get w is from -1 to negative of square root of -z. And this is the same as what we did before, but with the w range from -1 to negative square root of -z, we get this integral, we solve it out, and these two cancel out, right? Since z is square root of -z times square root of -z. And right, these two cancel out, and we get 3/2 of z plus 1. So when z is positive, we have 3/2 times 1 minus z, and when z is negative, we have f of z equal to 3/2 times 1 plus z. And this is the corresponding graph. When z is equal to 1, fz of z is 0, and when z is -1 is 0, and when z is 0, they are both 3/2.